Assalamu alaikum. This is chemistry 12th, and as we are discussing the chemical properties of these carbonyl compounds, we have discussed many chemical properties. Now there are many more chemical properties which we are going to discuss in today's lecture. In our today's lecture, we already discussed a number of chemical property and chemical reactions of these carbonyl compounds in our previous lecture. Now today we have got since the topic is these nucleophilic addition reactions followed by elimination. Now the reaction with ammonia. This is the reaction of these aldehydes with ammonia. Now aldehydes accept this formaldehyde. They react with ammonia to form this aldehyde ammonia adducts. You can see here this is an aldehyde I have shown here. This is acetaldehyde or ethanol. Upon reaction with this with ammonia, it gives this ethanol ammonia adduct, which on warming loses water molecule to form the imine or acetal imine. Now as far as this formaldehyde is concerned, formaldehyde, it reacts with ammonia to form hexamethylene tetraamine. Now the hexamethylene tetraamine, this is also commonly known as urotropin, as it is used for the treatment of this urinary infections. You can see here this is the 6 molecules of this formaldehyde. They react with 4 molecules of ammonia to form hexamethylene tetraamine. You can see here this is the structure, and these also now 6 molecules of water are also here given out. So this is hexamethylene tetraamine. Then we have got one more reaction, that is the reaction of these aldehydes and ketones with these primary amines. Now in this reaction we see that they give rise to the formation of a Schiff's base. So we see here in this reaction Schiff's base is formed. You can see here this is an aldehyde. It reacts with a primary amine, and it gives us this is Schiff's base. For example, I have shown here this is benzaldehyde. When it is treated with aniline, this is aminobenzene or aniline. When it reacts with this benzaldehyde, and it gives rise to the formation of this Schiff's base, or it is ethanol aniline. And it is this ben and this is benzyl diide aniline or benzyl aniline. Now then we have got this reaction of these aldehydes with this pentahalide. This is phosphorus pentahalide. You can see here this is PCl5. Now in this case gym dihalides are formed. Here I have shown here this is a carbonyl group. When it reacts with this pentahalide, it gives rise to formation of this gym dihalides are formed, and plus phosphoryl chloride is also formed. I have shown here, you can see here this is ethanol. When it is treated with this pentachloride, phosphorus pentachloride, it gives us a gym this dihalide. This is 1,1 dichloroethane or dichloride plus phosphoryl chloride. Similarly, you can see here this is propanone. It is a ketone. Now when it reacts with this pentachloride, phosphorus pentachloride, we get a gym dihalide. This is 2,2-dichloropropane plus phosphoryl chloride. Then we have got this oxidation reaction of these. As I have told you, there are it shows different types of reactions are being shown by these carbonyl these compounds or carbonyl group. Now one more reaction, that is the oxidation reaction. Now aldehydes and ketones, they get these, as far as aldehydes and ketones, we see aldehydes get easily oxidized to carboxylic acids on treatment with common oxidizing agents, like we have got this is alkaline KMnO4, or we use this acidified potassium dichromate. Now you can see this is an aldehyde I have shown here. This is ethanol or acetaldehyde. Upon oxidation, it gives rise to this ethanoic acid. Now as far as these ketones are concerned, Now ketones, they are not easily oxidized by these oxidizing agents. However, under drastic conditions, that is using a powerful oxidizing agent like we have got this this we have got this concentrated nitric acid, or we can use these KMNO4 acidified, that is we use concentrated sulfuric acid and KMNO4, or we acidified potassium dichromate. In that case, we see that the cleavage of the carbon carbon bond takes place, and it gives rise a mixture of carboxylic acids having less number of carbon atoms than the original ketone. You can see here, this is acetone upon oxidation with this oxidizing agent used here is, it is concentrated again nitric acid. So we get a mixture of two acids. This is acetic acid or ethanoic acid and formic acid. Then we have got certain reagents which are used to distinguish between these aldehydes and ketones. So one of the reaction, that is we have got certain reagents. I have told you then that we have got tolerance reagent, we have got Fehling solution, we have got Benedict solution. So these are used to distinguish between these aldehydes and ketone. Now as far as this tolerance this reagent is concerned, it is an ammonical silver nitrate solution. So when heated with this tolerance this reagent, these aldehydes, they reduce silver ions to metallic silver. I have shown here, you can see here, and this is you can see this is a silver nitrate. When it is it treated with this ammonium hydroxide, it forms a precipitate of silver hydroxide, then ammonium nitrate. Now this silver hydroxide, it reacts with two molecules of this ammonium hydroxide, and it gives us this tolerance reagent. This is diamine silver hydroxide. Now this tolerance reagent, then when it is treated with an aldehyde, and you can see it gives us a salt, ammonium salt of this carboxylic acid, plus we get this is silver mirror, water plus ammonia. Now this I have told you, this salt tolerance reagent, it is ammonical silver this solution of silver nitrate, and it is prepared by adding this ammonium hydroxide solution to silver nitrate solution till we get this precipitate of this silver hydroxide is formed and now this reaction, it is known as this reaction is known as silver mirror test. And we see that this silver mirror this formed indicates the presence of aldehyde group. Now as far as ketones are concerned, they do not give this tolerance tolerance test. Now then we have got another test, that is this Fehling solution. Now as far as Fehling solution is concerned, it is an alkaline solution of copper sulfate containing some sodium potassium this tartrate. Now when aldehydes are treated with this Fehling solution, we get a red precipitate of this cuprous oxide is formed. Now aldehydes give us this test. This Fehling test is shown by this aldehydes, whereas ketones they do not give this test. Similarly, we have got this Benedict solution. So in this Benedict solution, it is an alkaline solution of cupric ion complexed with this citrate ions, and it in a similar way it reacts with this it reacts with these aldehydes as we see in case of Fehling this Fehling solution. So these are the various types of reactions, and there are many more reactions like we have got reduction of these aldehydes. We have got Cannizzaro reaction, we have got aldol condensation, we have got this Perkin reaction, and those reactions we will discuss in our next lecture. This is for today. Thank you very much.